Hi, thank you for joining us. I think we'll get started now. I'm Nick Bray from NBA. NBA is an architecture studio based near City Hall in Vancouver on the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. For those of you that attended our last seminar, welcome back. For those of you that didn't, if you want to watch the overview of the changes in the 2024 building code, we will be emailing everyone a link to the recording of that seminar and of this seminar within the next few days. Based on the positive feedback we received, we're going to host a series of these events. The next one will likely be in September, teaming up with CarbonWise to discuss the zero carbon step code, also part of the BCBC, touching on cooling requirements and heat pumps. If you're interested in that, we will likely email you with further information after the summer break. My apologies to those of you that are soccer fans. I should have known better than to organise this session during two important games. If you're watching the Portugal game on your other screen, please feel free to give us updates in the chat box. But please be careful not to miss the link to register your AIBC learning credits. And we will be posting that link in the chat box towards the end of the session. Maybe Helen, you could put up that poll now. If hopefully everyone's will have a chance to let us know which category you fall into. My office has been working closely with both Celerity Engineering and Timber Engineering for many years now, and we very much appreciate being able to collaborate with both teams of experts. Celerity Engineering will present the adaptability code implications first with a short question session afterwards. I will then introduce Timber Engineering to discuss the seismic code implications, again followed by questions. So please feel free to write your questions in the chat box. Please be aware that we had, I think, close to 300 people sign up for this seminar, so we might not get to every question. Also, please, if you could keep your questions short, that would be appreciated. Before I introduce Celerity, I'd like to talk a little bit about timelines relating to this code update. The situation at present is that any project that has not been submitted for BP and accepted by the municipality before March 10th will need to comply with the significant unit layout and structural changes that we will be discussing today. That means that most projects that are being started now will need to be designed to these new codes. And you may even find that some projects have already been started will need to be redesigned to comply. However, the BSSB are currently investigating in-stream protection measures for the adaptability requirements. This may be in the form of a 12-month grace period for a BP submission if a precursor application has been submitted, i.e. if the project has already been submitted for either a rezoning or development permit application by March 10th, and that application has been accepted and paid for, there may be a 12-month grace period in which you can submit a BP application under the existing rules. But in classic BC government style, this in-stream protection is not confirmed or assured in any way. So unfortunately, the developers, which I think make up 4%, I'm looking at the poll results here, of the people on this seminar, the developers will have a difficult decision to make, whether to gamble and run with the old rules or play safe by complying with the new rules that we're going to be presenting today. With that, I'd like to introduce Brian Fraser from Celerity Engineering. Brian has been working as a consulting engineer since 2005, originally focusing on code consulting and fire protection engineering. He is now a registered professional engineer in BC, Alberta, and Saskatchewan, and has been a certified professional CP registered in Vancouver and Surrey since 2012 when he co-founded Celerity Engineering. Thank you, Brian.
Thank you, Nick, for the introduction. We very much enjoy working with your office as well, and over the past several years. Thank you, everyone, for joining today. We had a great turnout last time. It looks like we're headed towards that again today. Much appreciated. I hope everyone gets a lot of value out of the presentation. Today, Corey from our Victoria office, where I'm also located, will be presenting on the changes to the adaptability requirements of the code that are coming up. And she'll have a lot more comments about whether she thinks those are actually going to come through or not and so forth. So just a quick word about us. We're a full service building code consulting firm. We're located in Vancouver and Victoria, and we also have an office in Saskatchewan as well. So, Corey?
Great. Thanks, Brian. And thanks for everyone for joining today. As Brian mentioned, I'm going to talk about the adaptability requirements within the 2024 British Columbia Building Code. Before we dig into that, I just wanted to broadly discuss accessibility. And to do so, I think it's important that we talk about the accessibility requirements and their goal within the code, essentially to aim to support persons with disabilities. So with that, I'd like to just reiterate and state what the definition of a person with a disability is based on the definition in the code. It means a person who has a permanent or temporary physical, mental, intellectual, or sensory impairment, which in interaction with various barriers may hinder their full and effective participation in society on an equal basis. So as we see from that definition, it encompasses a large spectrum of individuals. So not surprising, the 2022 Canadian Survey on Disabilities found that 27% of Canadians 15 years of age and older had one or more disabilities that limited them in their daily activities. So this is, again, only 15 years of age and older, so there's a large population still unaccounted for. So it's not surprising we're seeing all this increase in awareness around making the world and everything more inclusive, and a shift in our really global movement to shift design and focus on inclusion, diversity, equality, accessibility, and sustainability, also known for its acronym IDEAS. And these changes within the adaptability requirements are just part of this movement. So I'll begin with a quick overview on what we're going to discuss. We'll touch base on the effective dates. We'll talk about accessibility versus adaptability. I'd like to highlight the design criteria changes and the adaptable requirements. We'll do an overview on design standards that can support accessible design, and just highlight a few of the design criteria for accessible paths, talking about interior and exterior that impact the adaptable units. So the effective dates, as Nick said, we are in the 2024 BC Building Code right now. It came into effect on March 8th. This had an exception, which was the application of the adaptable units and the earthquake requirements, which are coming into effect March 10th, 2025. So the delay on these dates with respect to adaptable units was aimed to target the housing supply shortage, product availability, affordability, and just general impact on industry. So what that means for everyone right now is that we're still applying the 2018 requirements, and that goes up until the date March 10th. As Nick said, March 10th is in here. There is possibility, some leeway, that 10, 12-month grace period. It's not confirmed, it's in the works, talking about it. It may, again, it will depend on permit submission, potential fee payments and whatnot. But from our perspective, we just recommend, where possible, reviewing, implementing these new requirements as soon as possible, even before the March 10th deadline. Again, with these deadlines, because it's not here, we don't know. There could be, we do anticipate changes or not. So we just move forward with the information we have now and do our best design. So to clarify things for the purpose of adaptable requirements, I just wanted to state the difference between accessible and adaptable. So accessibility, as defined in the building code, is an area in its facility or both, which is easy to approach, enter, exit, operate, participate in, pass to and fro, and use safely and independently by persons with disabilities. So these requirements are in place for buildings to accommodate people with diverse abilities, and so they can access and use the buildings. When we're looking at adaptability, that's the quality of being able to adjust to new conditions. So the adaptable requirements within the code are focused on residential, and we look at adaptable dwelling units. An adaptable dwelling unit, by definition, is a dwelling unit designed and constructed with some accessible features in which accommodates the future modification to some or more accessible features. So the emphasis here is on some features, including some features. So we acknowledge these adaptable units are not considered accessible. The intent is not for them to be fully accessible. The aim is to help people stay in their homes longer through illness, injury, aging, and just allow modifications at minimal cost to accommodate the occupants' changing needs. And so specifically, some requirements that we're looking for, it's heavily focused along clear space. And we think back to the intent of these adaptable units and being able to accommodate future modifications. You know, clear space is not something that we can just magically create. So a lot of the requirements focus along providing that clear space or having room to accommodate things further on. The clear space is focused in bathroom, kitchen, and the bedroom. We're looking at hallway widths, door widths, and locations of outlets and controls. So again, the adaptable requirements aim to minimize costs and limit the scale of an alteration needed within the unit to accommodate the user. So the adaptable dwelling unit requirements can be found in subsection 385. They are applicable to one-story dwelling units served by an accessible interior public corridor, accessible common building entrance. And so what this means now, moving forward, as of March 10th, when these become applicable, 100% adaptable units will really be required in residential apartment buildings over 2 stories or residential buildings larger than 600 meters squared. So this is a significant increase in impact on our designs. These micro suites we used to see, or we have been seeing, may no longer be feasible just based on this new clear space required throughout. I do want to emphasize that these requirements do not apply to detached houses, semi-detached duplexes, triplexes, townhomes, row homes, and boarding houses. There is a requirement for those types of buildings to have at least 1 bathroom with walls reinforced to accommodate the future installation of grab bars. But aside from that, it's not the intent. I want to highlight that the requirements within the adaptable units, they don't align with the VBBL at this time. We know the Vancouver bylaw is coming up with a new edition shortly. We're hoping that they will align, and that's what we're feeling, but like everything, we'll know it when we see it. So then we move into the construction requirements. There's not a significant change here. This article simply states that the construction of adaptable dwelling units and will conform to the subsection and the accessible requirements. What we see is an inclusion of clarification. So all this clear space that's required for different parts of the building are now permitted to overlap. So whether, as I've shown in this picture here on the left, whether it's a turning radius within a bedroom or a door clearance or access to the closet or a pathway, it's all clear space. So we can use that for anything. We don't need to separate each individual component of clear space. Within this article, there's also a little bit of clarity on what rooms. It doesn't require specific rooms in a dwelling unit, just states if there are rooms and they're within here, they should be designed to be adaptable. Next is the building access requirements found in Article 3853. This one states that access is going to be provided to common areas, spaces, and all common interior and exterior paths of travel serving the adaptable dwelling units. Anything that's not intended for residents, common spaces and paths are excluded from this. There is an inclusion for increased lighting to 50 lux in the floor area for a common corridor and passageway. This exceeds the 10 typically provided. Also provision for special outlet boxes in the adaptable dwelling units, just for the provision of future strobes. Doorways. At the next one, we see a revision here with the doors. This is consistent with the rest of our design requirements in 383, but the 850 clear width is required not only at the entrance door, but with interior doors as well. And just on the top of the screen on the right, it just reminds us how we measure that clear width. It is the clear opening. So from the stop to the open part of the door. As with all doors, we need a clear space around them. This article references and inconsistent with the design requirements in 336. So if it's a pull door, then we need the 1500 millimeters by 1700. As you can see in the picture, this clear space, the orientation isn't fixed. As we move on to the push door, the orientation is fixed. We need the 1500 perpendicular to that door, and then the clear width parallel is 1200. There's a provision that you're allowed to reduce these widths if it's a power door operator is provided, or even just provisions for a future install of one. And you can reduce it to the 1500, still perpendicular, but we're reduced down to a meter parallel that door. And then we have some hallway and corridor requirements. This is new inclusion into the adaptable unit requirements. So it defaults back to the requirements within 383, which is our adaptable or accessible width of 1 meter. This was an interesting inclusion, and we don't see it a lot throughout other buildings because we're governed by our egress width of 1100. But here with the adaptable dwelling units, these requirements apply within the suite. So we will be looking at that 1 meter for corridors and hallways. There is an allowance for that to be reduced to the 850. And that's just for small indentations of 600 millimeters or less. Bedrooms is another new one. It requires that 1 bedroom in an adaptable unit be provided and consistent with the requirements in the code. This bedroom should be designed to accommodate a bed that sleeps 2 people. Consistent with our occupant load, we have 2 people per sleeping room. So a bedroom designed to be accessible should accommodate a double bed. The requirements specific to the bedroom, looking for a clear space of 1700 meter diameter or 17 by 1500 millimeter clear space. The wording within this article is a little vague, and it says it could be adjacent to the bed. When you further read into the notes, it seems like the intent of this is to help with the transfer into the bed. So adjacent to the bed seems like a logical and helpful location, but again, that is not specifically written in the code. The next requirement for a bedroom is a clear pathway of 850 wide. And this is not to be obstructed by furniture, just to provide use of a bedroom. This would be applicable, especially if there was a window or something on the far side of a bedroom. Everyone, we need to functionally use that space. And then the last requirement within a bedroom is closets, the clear width of a closet opening, 900, and then a clear space in front of it. Similar to that 1700 millimeter diameter or the 17 by 1500 millimeter open space. Again, this is references our allowance for overlap. And as we can see, this is a large area provided. So overlap of those spaces is permitted and definitely beneficial when designing a room. Bathrooms. The design of a bathroom often requires a little bit of extra attention. Have more plumbing, we have different fixtures that come into play and replacing needed. So the goal here is just if we have to retrofit a bathroom, that we can do so without like major renovations. So the requirements within this article lean towards a clear lateral transfer space beside a toilet. Again, more room. We have the location of the water closet within a proximity to adjacent wall. This is where we'll have the future grab bar locations. The other requirement is for plumbing systems to accommodate future install of an accessible sink, an accessible shower or tub. And then also these are not permitted to impede the use or space of other fixtures within. So plumbing systems, as clarified in the notes, addresses the water supply, drainage, and venting systems. So again, we just want to be able to replace the systems without major impact and redesign. This one has been brought to our attention, especially drains, and a drain for an accessible bathroom sits a little bit different than a drain for a shower or bathtub. So these things caught early and designed early can really be beneficial. The last requirement is that we have the walls that are reinforced for the grab bars, and that's adjacent to the toilet, as well as a shower and tub. And then we have kitchens, another area we need to have accommodate adaptable requirements. There is a requirement within here for the sink and cooktop location. It says adjacent or with a continuous counter. This one is in the code just for usability. I'm not sure how strict we are on this. We have not seen these type of requirements for placement of these 2 features in a kitchen. No, the CSA B651 doesn't specify the location of these two fixtures. So if you had a parallel kitchen, one could be on one side and one on the other. But based on the code, adjacent typically means touching. So we're just going to be conservative and assume they're all going to be on one side, one counter, either beside one another or adjacent. The other revisions within a kitchen, we need clear space. Again, back to the 1700 diameter or 1700 by 1500 millimeter. This is usability within the kitchen. We want it designed to accommodate the future install of a kitchen sink. So here the focus would be on knee clearances and locations of the plumbing, vent, and drain. When we talk about kitchens, we often have a kitchen that includes that popular design with an island. And the question is that still possible? Well, I guess that kind of comes down to the interpretation between fixture and furniture. So in our opinion, it is a design that included an island is definitely still possible, but we would want it more to be on the side of furniture. So it could be removed and not really impact. So you wouldn't have appliances or sinks or plumbing or electrical stuff that would go to it. We'd have finished floor underneath so that it could be removed. The clear space would be provided and really not impact the functionality of the kitchen. Again, this one's open for interpretation, but that seems to meet the intent. So a furniture island would be permitted, not necessarily a plumbed in and fixed criteria. The last requirement within the adaptable units falls on the controls, switches, and outlets. There is really no significant change here. Our reach and everything we have lowered at the minimum location is 400 millimeters. It used to be 450, pretty minor, and up to 1200 millimeters above the floor. Again, this applies to things that we're using. It does exempt controls that are dedicated for equipment or appliances. So as we conclude the adaptability requirements within 385, before we move on, I just wanted to bring our attention to these other kind of design aspects that are nice to consider as we're moving forward. One is the window location. Specifically in the BCBC, there's no requirement for a window location, no reference, no nothing, but we do see within the CSA B652 adaptable dwellings, a reference that one window should be provided in each room, located not higher than 750 millimeters from the finished floor, an exemption to the bathrooms. And then this requirement is equally reiterated within the VBBL. We have one window. This is within the living room. It's located 800 millimeters above the finished floor. Again, it's not within the BCBC, but it is a functional and kind of a large item if you were in a unit and you wanted to make a revision. So these are things to consider as we move into design. The other thing is patio doors often bring up another issue. It's a gray area. There's no requirement for it to access specifically right over into the balcony or patio, whichever the unit has. Although looking at patio door, threshold, and swing type early on may just simplify a unit and be designed for all. Other little funny things we bring about that people see as they go into units that are designed to be actually accessible would be stacked washers and dryers. Unfortunately, sometimes these upper units aren't reachable for people with limited mobility. So we're not saying we need to design them side by side, but maybe allocate space and make sure that option could be available. These are just mindful design criteria, not enforced, but things to keep in mind. And now I'd just like to reiterate all the accessibility design standards and references that are out there. We know now that we have the CSA B651 2018 edition, which is the accessible design for the built environment. This one is now included in the 2024 BCBC. It's a direct reference, so it does make that standard now enforceable within. Do you want to highlight there's a new version of the B651? There's a 2023 edition. This one didn't quite make it into our 2024, so it gives us a chance to look forward and see what's coming. This table on the left, I just highlighted some of the clear space requirements and the differences. As you see here, the turning space that's bubbled on the far right is 2.1 meters. So right now, our designs incorporate this 1700. So when we feel that that's big we're trying to incorporate it into our design, just remember that based on design and feedback from users, the 2.1 meters is preferred. So just giving that 1700 feels, we shouldn't grumble about giving up extra space. Anyways, within that, the 2023 edition has moved all requirements associated with accessible dwelling units into a new standard. That's the B652. So that's a new standard. Again, these ones are just standards, so they're used for guidelines and not enforced. And then before we close, I just wanted to touch base on these impactful changes within the accessible requirements. The dwelling units are required to be served by an accessible path of travel, both interior and exterior. Within section 3.3.2, accessible paths of travel, we have a new requirement addressing long corridors. And it definitely depends on the width of your corridor. So right now there is this new inclusion for a turnaround or a mobility zone. And that comes into play when we have a corridor that's more than 12 meters in length. And if the corridor is not 1500 or more, we do need to incorporate a turning zone at the end. Once we have corridors greater than 24 meters, we actually don't care about the width of that. We need this turnaround zone or maneuver zone regardless. And that has to be incorporated at intervals not greater than 24 meters. And it's a 17 by 17 millimeter space. Secondly, I just want to highlight the changes in the exterior walks. We have an increase in our width required on the outside of the building. We're looking now to provide 1600 millimeters. There's added clearances around entrance doors on the exterior where we go to that 1700 by 1700 millimeters. And we do have a direct reference here where we are required to comply with the CSA B651 requirements for exterior walks, and the provisions there, they include a broader scope than previously within the building code. We're looking at, overhead obstructions. We're looking at separations from vehicle walks. We're looking at specific requirements for tactile attention indicators and where bolsters are. We have separation distance between them. Just a lot more things to incorporate, and this isn't to go over them all, but just to be mindful, we need to dig into these deeper as we move forward. And I think that sums that up for a quick deep dive into the adaptability requirements from our end. I'm not sure if we want to take any questions now or if we're just going to leave those to the end.
We've got 5 minutes now to just talk through some questions here that we have. But I mean, before we get into that, I just want to say that there's still a lot of things, obviously, that we're unclear about that we need clarity on from BSSB. From the BC government. And also we can only present what we actually know to be written in the code right now. But I know, for example, there has been talk about the requirement for a double bed and the requirement for a space on both sides of the bed. And it's looking towards, and I'm not sure if it's been confirmed or not, but it's certainly been discussed, talk about that only being required on one side of the bed and it not being it not necessarily being a two-person bed that is required. Now, again, we can only really present what has been written in the code at this point and or confirmed at this point. But just be aware that we are seeking clarity on another number of issues, and maybe we can keep you updated with those items. Just to start on the questions here, a question from Tina here, and I think you did actually get into this. Does the BCBC include requirements for windows that are accessible? You did answer that. For example, latches for swing windows are at the height that a person in a wheelchair could reach to provide fresh air to a room.
I think that's kind of just built into well, obviously, as we said, the BCBC doesn't have a requirement specifically for windows. The VBBL and the CSA B652, who reference a window in their location, they do say operable. So if it's an operable window, that I think leads to the fact that whoever is trying to use the window would be able to use the operable features of the window.
Susie asks, does the BCBC include requirements for windows that are accessible? We'll move on to the next one. I think we've covered a lot of this ground already. Eric asks, for bedrooms, is the 850 millimeter requirement on the other side of the far side of the bedroom, is that clear? Is it clearly defined?
No, definitely not. Again, they just use it as a pathway to kind of use the functional use of the bedroom, so they couldn't keep it any more gray and open for interpretation. And so like you said, Nick, there is a little bit of back and forth and no one's clear on whether we do need that double bed, if it can be against the wall or if we need it beside. And I think there is right now, we've even heard people with different municipality feedback on their different interpretations. So from a functional and user point, I would see it's beneficial to be able to provide it right around. But as a designer, I think that is a safer design, but it could be definitely battled and argued and had a conversation with the AHJ.
Fair enough. Question here about the required percentage of dwelling units that must be adaptable. That's in BC, that's 100%. Do balconies require, are the balconies required to be accessible?
So balconies are not targeted within there. When they talk about dwelling units, they're talking about the interior space. So I think good practice would be if you're in there to have access, but again, it's not an accessible dwelling unit, it's adaptable. So if design can incorporate a patio door or a balcony door with a threshold that meets accessible requirements, that's great. It's something that we should be flagging, but not specifically required by code, just good practice.
Fantastic. Is the required 1000 millimeter corridor clear space sufficient for access to linen closets, pantry doors, and the like?
I think the 1 meter clear width in the accessible requirement comes from supported actually within the B651, and it just comes from a wheelchair. They require a clear space for a sitting wheelchair at 800 by 3550. So the 1 meter is kind of just a little bit of that with a buffer. So to access, that should be sufficient. I do like to reiterate that it's not an egress or exit width requirement, just this number for access, for accessibility.
This question from Igor. Increasingly, the 1700 by 1500 clearance at doors is now counted from the frame, not the door. Do I have that right?
I think that's include that new 1700, especially if it's exterior, it does include that clearance on the latch side. So we used to focus on making sure you had the 600 and the 300. The pull side, that's kind of incorporated now into that open clear space at entrance doors. Not sure if that's the.
Yeah, I think that answers that. Victor is asking about the CSA B651 permit. The common corridors to be 600 millimeters rather than 1500. He wants clarification on that, and that actually ties in with another question here that is about clarifying where corridors need to be 1100 versus 1000 millimeters wide.
Right, so the 1100 would apply to exits, egress when we're within the actual dwelling unit. That is just considered that space. So we don't, that is where for accessibility, you're looking for the 1 meter.
Fantastic. I think there's one last question. I think we've just got time for this. It's about dead end corridors, which the question is, have they been increased from the 6 meter requirement?
No, not to my knowledge.
Fantastic. Well, we've got time for a few more questions at the end when we finished up the seismic side of this, but I think it'd be great to switch over to the seismic presentation now. Thank you very much, Corey. I'd like to introduce Robert Malchek. In 1997, Robert co-founded Equilibrium Consulting, and through his career, he's worked on over 600 projects, many of which have won awards. More recently, Robert co-founded Timber Engineering. He's currently working on projects all over Canada and the USA and in Asia. His speciality is a system approach to mass timber with emphasis on structural and energy efficiency. Thank you, Robert.
Thank you, Nick, for this introduction. We are Timber Engineering, a new structural engineering firm, just 3 years in business, but as Nick said, lots of local experience after running and starting Equilibrium for 21 years with my partner, Rick Karsh. I started Timber Engineering with Marta and her son and a few others from EQ. We do a lot of local projects, but also work in the US and work on overseas projects. On the code side, I sit on the CSA 086, which is a timber code, and you know, for the last 25 years, and every few years I give these seminars on what is changing in the codes. And this seminar that we're doing right now, it's about the seismic code and what can we expect from the seismic design for when we apply with BCBC 24. So if we can have a next slide, please. So there are 4 important changes that you should remember. First of all, the higher seismic hazard. So there will be an update to ground motions, which will require in higher design loads. And these are the things to remember. 45% increase in Victoria, 25% in Vancouver for low-rise buildings, and a much smaller increase for high rises, 5% increase in Vancouver, 25% increase in Victoria. So the low-rise buildings, they will be the ones together with mid-rise that will be changes. Now, there will be changes to site class designation and how we design for soils. There is a new approach towards performance beyond collapse prevention, and the new shear force resisting system types are being introduced. So there are a couple in steel, and what's really changing is the moderately and limited ductility CLT shear walls. So we have designed CLT shear walls for last 15 years. Now they're in the code, and now there is this big change. And no changes to part 9. Next slide, please. So what does it mean for developers, architects, designers? Buildings will become more regular in geometry. There will be more walls lining up, especially shear walls. There will be more shear walls. Transfers, irregularities, they will become much more expensive and harder to design. Other systems like CLT shear walls will be mixed together with load-bearing wood framing walls because it will be much harder to use these wood framing walls as shear walls, even with the rods. We already see projects with tons of build-up posts. There simply will be geometries that it will not work. And the other big thing is that the geotechnical engineers will be hired at the design stage. More and more of this is already happening, but now this information will result in huge savings to the design. Next slide, please. So that's how it goes from National Building Code into the BCBC, into the Vancouver bylaw. That's how it was before. Next slide, please. And that's what's going on now. So we are already getting into BCBC 24. We still don't know exactly when Vancouver will adopt it in the bylaw. So, but the process is the same as last time. Next one, please. So how was it before? So, you know, we started with 1941 with the first national building codes in Canada. Then we went pretty much to the 1980s. In 1990s, when I graduated from UBC, we were starting seriously to design in seismic, but in reality, it was the 98, 99, and especially the changes into the struct end designation, which we had to pass these additional exams in early 2000s. A lot of it was about seismic. So in 2000s, we really started doing it more. And now, you know, with 2020, 2024, and as much what's important to remember here is that the load path and the requirement for this load path was always kind of stated. Now it is in the code. Next one, please. So now I will pass to Alicia, and she will be talking about the key concepts.
Hello, everyone. I want to just introduce the few technical concepts that are important for us to really understand where all of these big changes are coming from. And one of the first concepts is how does the actual localized site will react to earthquake. As you can see on the figure here, even within the Metro Vancouver area, we can have vastly different site conditions. This ties back to what Robert said about hiring geotech early, because one of the main ways that we actually assign the site class to our buildings is the average shear wave velocity measurement, which is the speed with which our seismic wave can travel through the site. And that is used for the site class designation, and at lower velocities, we can say that our soil has lower density, and that will result in higher seismic loads that the site will see locally. Then the second important concept is, of course, how much will my building shake? And this will depend, of course, on the location within the country, with the higher seismic zones being closer to the potential epicenters. It will also very much depend on the structural system, the height of the building, and the concept that I've just introduced a second ago, how fast that earthquake can travel through our site. And typically, all of this is encompassed in our spectral acceleration. And that value of spectral acceleration, historically, we've been able to access it from an Appendix C, but now from the 2020 NBC and consequently BCBC 2024, this will be done through an online hazard tool. Just to zoom in a little bit on what changes are to the seismic spectral acceleration values. This is the map on the left-hand side where you can see across all of the Canada. But of course, we're focusing a little bit more on our local BC. And as Robert already briefly mentioned, when we think about two most important cities for us locally, especially seismically, Vancouver and Victoria, 25% increase in that spectral acceleration in low-rise buildings for Vancouver and 5% for high-rise. And then for Victoria, this is 45 for low-rise buildings and 25 for high-rise. And just to underline, because this is directly impacting the spectral acceleration values, directly impact the loads, the calculated loads on the building. I also would like to highlight that this, as you can see at the bottom right corner, is one of the biggest peaks that we've seen in those ground motion models in terms of hazard values throughout the years. And therefore, it is going to impact the way that we will design quite significantly. Also, just going back to that online hazard tool, the ground motion models are going to be much more site-specific now. We used to have just under 700 data sets, which were in that appendix that I've mentioned. Now we have over 300,000 data sets. So there will be varying very much, not just within between the cities, but within the city. So it's going to be very, very focused. And this is why we have the online hazard tool instead of it being an appendix, because it is incredibly hard to fit 350,000 data sets in an appendix. Just to show, for example, how it will work for an example design, you can see on the left-hand side here, this is an example building, our office. It's localized in Vancouver, and despite the changes being summarized for 25% increase for Vancouver in general, when we localized for site specifically, you can see that recalculating between the old and new hazard values, we will see around 13% increase in those base shear values. So it is very important to understand that we will be needing to know exactly the site specifics, and we can preserve a lot of efficiency of the design in that way. In our building, for instance, this is foreshadowing a little bit to what Christian is going to talk in a minute. We already have designed this structure for performance that is going to be damage-free after seismic events, thanks to the use of the technology called Tectonus, which the hold downs is installed as hold downs in our shear walls. And it allows for recentering of the structure after a seismic event, especially at the lower seismic events that are more likely to happen more often. And one of the really important things that is going to be vital for preservation of the efficiency of our design is that now the codes have been changed, and it's been designed into the codes that is going to be way less efficient for us to just use site class designation. It's still going to be possible to do so, but what the code designers are really trying to encourage us to do is to, instead of the bigger brackets of from A to F, to use a specific shear wave velocity. And that is because what it used to be, like you can see in the graph on the right-hand side, the dotted purple line is what the 2018 site class designations would have meant. Means that within the bracket of a site class, we more or less get an average value of the spectral acceleration. And now the way it's going to be looking like is that it's going to be the worst value. So if we just say we're designing for site class C, we're going to get the worst possible design value out of the entire site class. And this is exactly what Robert mentioned, that we will, in order to preserve that efficiency of the design, hiring a geotech early and being able to know exact site class acceleration, shear wave acceleration for the specific site, will allow us for a more efficient design. And now I'm going to pass on to Gersand, who is going to talk more about the upcoming changes.
Yeah, thanks, Alicia, for the introduction. I'm Gersand Bidibita, and I will just take you through the last remaining portion of the presentation today. So based on what Alicia and Robert had mentioned earlier on in this talk, is that it's worth mentioning what exactly we have been doing so far. So let's say the way Robert mentioned that the seismic design really started in early 2000 up to the NBC 2015. What we have been doing so far, it's really just to design for a single performance objective. And that objective has really been just for life safety, right? So we've been designing buildings as the picture on the right-hand side is showing. So to just make sure that those buildings don't collapse. So it's for collapse prevention and try to save lives. And with that, the code has never really given any other additional requirements except from when you have different structure, like the high importance buildings or post-disasters buildings. There are those few key points that you have to consider, like increasing the load using the importance factor or reducing the deflection of the building as it shakes with a reduced drift value, or basically making sure that your structural system has is regular or efficient or symmetry in order to understand really what is the load path. And these are really just additional, I would say, key points that the code has given with no additional restriction or no additional analysis that has to be done except from making sure that the building do not collapse. So now, around the world, people have been asking themselves, especially after the earthquake in Christchurch in New Zealand, like there was the whole city, the entire city that basically had buildings that did not fail or did not collapse, but those buildings really couldn't have any occupancy after it. For example, the photo right on the right-hand side there, this building, nobody can even come closer to it to try to stand next to the building because of how badly it is damaged. So what do we define really as acceptable damage? Alita, next slide, please. So what does the code did for to add in terms of additional performance? So the code did add another level of safety here. So in addition to making sure that the building should not collapse, there is an additional requirement that basically requires the engineer to also check what is the performance of the building with lower seismic hazards. So these are the two graphs that you should keep in mind with this presentation. On the right-hand side, with the load displacement curve, so the bottom horizontal axis shows the displacement and the vertical axis shows the load. So what does this say? So when you have an earthquake shaking the buildings, you do have forces going into the different members. So up to NBC 2015, what we have been doing is that we have been doing for this point that is mentioned as ultimate. So which means that you have to make sure into the highest seismic ground motion that the building will be seeing is that to be sure that your building will not collapse. And that was it. But the second level of check that has been added into the code now is to be sure that at lower seismic hazard or lower seismic forces that the building will see, the building should remain elastic. By elastic, it means that yes, you will have some deformation. The building will go left, right, or whichever direction that the seismic forces will be sending it. It has to be able to come back to, I will say, to its original position with very minor damage that will not be causing the building to not have the performance that it was intended to do. So that's the elasticity that we are talking about here. So to be sure that a lower seismic forces, your building should maintain its functionality. So that's the second requirement that the code has asked in terms of performance and objectives. So on the left-hand side, what we are trying to do or trying to say in those slides is that you actually have different levels at which you have to design your building. So the first one is to make sure that at a return period of 2,475 years is the 2% in 50 years probability, is that's when you have to be sure that your building do not collapse. But at any seismic activity that would be lower than that, at 975 years or 475 years return period, you have to be sure that your building remains elastic, especially if it's a post-disaster building or a high importance building. Next slide, please. So what does that really do to us in terms of design? So now that you are seeing more restriction, now that you are seeing more limits, now that you are seeing more, or now you have a second performance that you need to meet. And as Robert and Alicia mentioned earlier, you actually have even higher forces that you have to design for. What does it mean to us in the building industry is that now you have to really try to target to have a much more regular building, a much more symmetric building. And by symmetric is that these are the two examples that we find that basically better described this word, is that you need to try to make sure that your lateral load resisting systems are located in such a way that you have a proper load path. And by proper load path, it means that you have the loads that goes from the top, the roof, all the way to the foundation. So on the left-hand side, you have the cores, for example, in gray that we highlighted there. And the blue lines are actually drag strapped. So that means that they collect the forces from the outer side of the building and bringing them back into the main side of where the lateral load resisting system are. And that is pretty symmetric. You can see that the two cores are located right at the position that creates a better load path for the building in plan. And the one on the right-hand side, if there is, for some reason, the architect or the design teams prefer to have perimeter braces or shear walls, you can see that at the perimeter, you are actually also trying to have a symmetry. You're trying to have something that is simple and more regular to be able to carry on those forces. And on this slide, the main important thing to remember here, and Robert will also mention that on the next slide, is that with those higher forces, with those second performance or objective performance required, you actually have to try as much as possible avoiding any transfer in terms of the lateral load resisting system. So try to have your cores and try to have your shear walls, try to have your braces that are very aligned from the roof level all the way to the foundation. This way you are actually optimizing your structure and making sure that your structure will perform better and will avoid any increase or cost premium that might be caused by you shifting from all direction the lateral load resisting system. So these are the main things to remember about what the changes in terms of performance structurally will be impacted from 2020. Next slide, please. So the other important point for us to remember here is the introduction of the CLT as a shear wall. So what this means to us is that, yes, we have seen CLT buildings for years now, almost more than a decade now here in North America and in BC. And so far, we didn't really have anything on the code that specifically gives you the RD and R naught factor for CLT shear walls. So now it is in the code, which means that we can freely design CLT shear walls without us having to go into alternative means and method or doing or additional analysis. But that being said, is that what is in the current code so far is mainly limited to what is called the platform construction. Next slide, please. So by platform construction, it means that just like we designed plywood framing, right? So you have the walls below that are supporting the floor above it, which can be used as a platform to allow construction of the next floor above. So on the left-hand side, you can see what is a platform construction, but most of the CLT shear walls that we've been designing so far, especially here in North America, are more into the balloon type of construction, which is in the right-hand side. Although this is yet to be in the code, there are many different research currently being done at universities and different institutions trying to also push this innovation or this system forward to be able to account for it on the next upcoming code. Next slide, please. So that was it, and I will pass it to Robert and to finish off the presentation. Thanks.
So one more time, higher seismic hazard will increase the forces. There will be a very large increase in Victoria, 45%, 25% in Vancouver. It will be the low-rise and mid-rise buildings that will be affected much. Now, the increase for high-rise, 25% in Victoria and just 5% in Vancouver. The site class designation, it's really important. We used to only get the site class B or C or D from the geotech. Now is the shear velocity that we will be asking the geotechnical engineer. Now we need this right before the design. There were many projects that I have been involved that we just assumed site class C because or D that was in the area of what we did before, and the geotech was hired later just to verify the allowable soil bearing pressure. Now this will become not that economical to do it. So we will be changing that. Performance beyond collapse prevention. This is for the buildings of higher classes, so schools and community centers. They will be designed for design that will not have too much damage. And then the new shear force resisting systems, CLT walls in platform construction will be game changers. They will be mixed with wood frame, and they will be providing these new solutions. Next one, please. So what does it mean one more time? Buildings will be more regular. They will be more lined up. There will be more like we used to do buildings 100 years ago. Walls, there will be more shear walls. Transfers and irregularities that were so easy in wood frame buildings will become much more expensive. And then other systems will be mixed into this. And what's really important, work with the geotechnical at the design stage. We would like to stress that these are the changes that will need to be worked together with engineers, with architects, right at the concept stage. You know, we all started working on projects, those of you that have lots of experience, where we would just get architectural design and then put our shear walls in. This will become not an easy way to design, and it will result in buildings that are not optimal, which will result in higher prices. So more and more towards this early work together between architects and engineers to address these seismic changes. Thank you. Any questions on the seismic?
Yeah, it's before we get into that, Robert, I think we're pretty much bang on time here. We're dead on 1 hour, so thank you very much to Robert, Lisa, and Hersend. Maybe I think Helen's about to put up the AIBC link to get your CPD points. So I think this is the only time you get to do this. So please click on that link and just fill out the questionnaire. Just a couple of questions here on the seismic side. For me, I think 85% of the people watching this seminar are architects. We discussed previously when we should be bringing on board a geotech and a structural engineer. I know you briefly talked about this, but how does this affect that process? And obviously structural engineers always want to be brought on straight away, and understandably, but can you stress how much more important that is now to engage geotechnical and structural engineers earlier on in the process?
It simply results in cost reduction, because if we can line up our shear walls, if we have enough shear walls, then we do not have to go to these expensive ways of stabilizing the buildings. So it is a matter of price right now, and I think developers will quickly realize that working together right up front will result in cheaper buildings. It comes down to that.
Fantastic. Josh asks, how will this impact concrete buildings, specifically core opening headers?
There will be impacts on concrete buildings as well. What we actually suggest is that we can Nick do a future seminar on wood and mass timber and what will be the impact into the materials. And there are several specialists in concrete, and they should be addressing exactly these questions. It's not a simple answer, and I think we should be going into the whole concrete part, another seminar just to go into concrete buildings.
No, fair enough. Aaron asks the question we all want to know, but is almost impossible to answer. Any estimates on the increase in construction costs as a consequence of adopting these new seismic codes?
We all know that the seismic cost of the building is between 16 and 20% of the overall cost of the building. So yes, there will be an increase, even with a 5-10% increase in the cost of structure. This will be the 5 or 10% increase on the 20%. So overall, 2, 3, 4%. It will not be that much if buildings will be designed properly. But the increase for the buildings how we used to design with lots of transfers will be much higher. Of course, it's impossible to say how much.
Yeah, I think that's pretty much all the questions we have here. Is there anything else you'd like to add from your end, Robert?
No, that's it. Thank you very much. And for us structural engineers, this is becoming a very challenging time to explain all of this to Nick, to you, to the clients. But we're looking forward to creating better buildings. Thank you for this opportunity.
Fantastic. Yeah, thank you very much to Helen in my office for organizing this, and to all the speakers. As I said, yeah, we'll be looking to put on our next seminar in September, and it will likely be on the zero carbon step code, which is also in the BCBC, and some relating subjects. So we will be emailing everyone updates on that, and also we'll be emailing everyone a link to this seminar recording and the previous one as well. Thank you very much for joining us, and yeah, have a fantastic summer. We'll hopefully see you soon. Take care.